We continue our discussion 1.3 Technique of Integration Part 3. This video, we want to find the integrand by using the partial fraction. Before we start, we will look at the partial fraction. So, first thing, you must make sure that the power of numerator must less than from the power of denominator. Okay. So to find the partial fraction, we can check the factors of denominator. From here, denominator is dx. So you can make a partial fraction depends on linear factors, repeated linear factors, and quadratic factors. So for example, when we have function x and denominator x minus 1 and x plus 2, this one is degree 2. So partial fraction is a over x minus 1 plus b over x plus 2. We have 2 over x in bracket x minus 1 all squared. So we can get the partial fraction by using a over x plus b over x minus 1 and plus c over x minus 1 all squared. This one is repeated factor. Next function, x minus 2 over x multiplied by x squared plus x plus 1. This factor cannot be factorized. So the partial fraction a over x plus bx plus c over x squared plus x plus 1. This one, denominator, one of denominator cannot be factorized. So we can make a partial fraction by bx plus c over x squared plus x plus 1. Okay, we'll look at the first example. Find the integration 5 over x multiplied by 1 minus x. So the first step, express 5 over x multiplied by 1 minus x in partial fraction. So this one is the different factor. So the partial fraction is a over x plus b over 1 minus x. So we can eliminate the denominator. So you can get the 5 equals to a multiplied by 1 minus x plus bx. So by using any value of x, you can get the value of constant a and b. Let's say when we substitute x equals to 1, so we can get b equals to 5, and when x equal to 0, so a is equals to 5. Okay, so the integration 5 over 1x multiplied by 1 minus x dx is 5 over x plus 5 over 1 minus x. So from here we can get the integration of this function. So integrate 1 over x, we can get the ln x, and integrate 1 over 1 minus x, we can get the ln 1 minus x. So differentiate the denominator, we can get negative 1. So negative 1 multiplied by 5, so you can get negative 5 ln 1 minus x plus c. Okay, so by using the properties of ln, when we have the negative, so we can write the ln x over 1 minus x. This is a last answer. Okay, second example. Use the method of partial fraction to find the integration of 2x minus 1 over x squared minus 2x minus 3. So 2x minus 1, the denominator can be factorized. So we can get x plus 1 and x minus 3. So the partial fraction is a over x plus 1 and b over x minus 3. So when we multiply all the terms by denominator, so we can get the 2x minus 1 equals to a multiplied by x minus 3 plus b x plus 1. Using the any value of x, we can get b and a, any value of x. Like say when x equals to 3, substitute left hand side and right hand side, we can get the value of b. And when we substitute x equals to 91, substitute into left hand side and right hand side, therefore we can get a equals to 3 over 4. So from this question, the integration can be changed into the partial fraction. So we can get integration of 3 over 4 x minus 1 plus integration of 5 over 4 x minus 3. So from this one, we can get the integration 3 over 4 ln x plus 1. And the second integration, we can get 5 over 4 ln x minus 3 plus c. Okay, so you can try this exercise. The answer is 3 ln x plus 2 plus ln x squared plus 4 plus c. Okay, that's all.